Okay, this is a continuation of 2.5 from the last video, which was Friday. I just wanted to go over this section again because there was a little bit of trouble. What we're doing here, the idea is you have some zeros and you're trying to find the function to those zeros. But more specifically, we're dealing with complex zeros here. So let's take a quick look at the complex conjugate rules. Okay, this says complex zeros occur in conjugate pairs. So what this is saying is that if you have some polynomial f of x and it has a real, a zero that's a plus bi, then its conjugate a minus bi is also a zero. Which should make sense because if you remember from the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a, well, the plus and the minus would make it the two solutions. So for example, if one of your answers was 1 plus 3i, then the plus and minus would tell you that the 1 minus 3i is also a solution. That's what that statement is saying. So even if you had, let's say, 1 plus the square root of 5 over 2, then its conjugate would also be a solution, which was 1 minus square root of 5 over 2. And again, that goes back to the quadratic formula. So that should make sense. That's what that statement's saying. Again, if a plus bi is a 0 of the function, the conjugate a minus bi is also a 0. Okay, well let's go back to what we know about factors and solutions. If we knew, this is just hypothetical, if I know that x equals to 3 and negative 1, if those are solutions, then we know that x minus 3 and x plus 1 are factors. Okay? Well, same idea with this. If I know that a plus bi is a solution, I can write it as factors. But all of your factors will be of the form x minus whatever your 0 is. Okay? It'll always be like that. X minus your 0. X minus your 0. So that's why when you write factors for your complex solutions, it will be x minus whatever your 0 is. Okay, this is your 0. Same thing here, this is your 0. Okay, so let's take a look at an example. Here we have, again, this is 2.5 continuation from Friday's lesson. Find all zeros of this function given that 1 plus 3i is a 0. Well, again, by that rule, if 1 plus 3i is a 0, then what should be a 0? 1 minus 3i. Good. Okay, so here's the big picture. I have this function. Okay, I have x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. If I were to factor that, I can't factor it now because it's 5 terms. If I were to factor this, it would be, there would be 4 factors. And I know that because of the fundamental theorem of algebra says there are 4 complex solutions, because of that 4 there. If I were to multiply all of these factors, then that means I would get that polynomial. Okay? Well, I already know 2 of the factors. 2 of the factors are with the 2 given solutions, x minus parentheses 1 plus 3i. I'll make that bigger in a minute. X minus 1 minus 3i. Okay, but I don't know what these 2 are. Well, if these are all multiplying, how do you think I can find these 2 factors? Or even better, you don't even have to find the two separate factors. It's just going to be one big factor. How will I find that one, this one here? If these are all multiplying, how would I find that remaining factor? I would have to divide. I would divide by this here. You would have to divide both sides. So what you're going to do is we're going to multiply these factors together so we can have just one polynomial here. Once I have this polynomial here, I'm going to multiply this, the x minus parentheses 1 plus 3i, x minus parentheses 1 minus 3i. Multiply this, then divide it. It's going to give me that factor, and then I'll be able to go from there. Okay, so let me go ahead and take this out. Remember, the factors were, I'm just going to put f of x, and that's going to refer to the entire equation up here. X minus 1 plus 3i times x minus 1 minus 3i. And I'm going to multiply that. Distribute the negative. I get x minus 1 minus 3i, x minus 1 plus 3i. If you multiply that, if you can go ahead and multiply that on the side, you could do box method, you could FOIL it out or distribute, whatever you want. I'm going to do box method. So I'm going to put x negative 1 plus 3i on the side. And when I multiply this out, I'm just going to go through the motions here. When you multiply this out, all of the i's will cancel out. So the negative 3ix, positive 3ix, negative 3i, positive 3i, and what does the bottom become? That's going to become plus 9 because remember the I squared is negative 1. All right, so when you FOIL that out, again, I have your function equals x squared minus 2x plus 10. Your function equals this times some other factor. You're factoring. So you're becoming very creative with your factors. The fact that I gave you those two solutions from the beginning, you're able to find this other factor by dividing. Remember, f of x is the original problem. So I'm going to divide my function by x squared minus 2x plus 10, and that's going to give me the other factor that's missing. All right, so I have x squared minus 2x plus 10 divided by, let me go back real quick, x to the 4th minus 3x cubed and 6x squared 2x, and I think it was minus 60. Let me see. Yeah. Okay, and you're going to have to do long division here because, again, you can do synthetic division with a trinomial. Okay, so long division, first one on the inside divided by the first one on the outside is x squared. When you distribute, you get x squared minus 2x cubed plus 10x squared. Switch the signs, and the x word cancels. You get negative x cubed minus 4x squared, bring down the 2x. Going fast here because, okay, and divide, again, the first one on the inside divided by the first on the outside. You get negative x. Distribute. Plus 2x squared minus 10x. Switch the signs. the first one cancels. You get negative 6x squared plus 12x, bring down the negative 60, and you do it all over again. First one on the inside divided by the first one on the outside, you get negative 6. And you shouldn't be left with any remainders or any remainder because after all, they are factors. And from those factors, you're going to find the other solution. Okay, so what did you just find? You found that the other factor, when multiplied to x squared minus 2x plus 10, will give you your function, x squared minus x minus 6. Remember, the first factor, x squared minus 2x plus 10, came from your two solutions, the 1 plus or minus 3i. That's where that came from. Well, what are these factors? How can you break the x squared minus x minus 6 down? If you did the diamond method, you would get x minus 3, x plus 2. When you solve, you get 3 and negative 2. With the already given to you, the 1 plus or minus 3i. Okay? I know that was pretty quick. This was in your book, section 2.5. I believe it was that last example. Let me go back here. So if you need a little bit more review, you can look in the book for that. Okay? All right, bye-bye.